Hey friends, and here we are. We've almost made it to the end of the rules for fractions. We just got to do adding and subtracting mixed numbers, which is today. Then we got multiplying fractions and then dividing fractions, and we're almost there. Sweet. I know fractions they're a lot of work, but they don't ever go away. So it's good to know how to do them. So like I said, today we are adding and subtracting mixed numbers. And I'm just going to throw this out here. In general, whenever dealing with mixed numbers, I'm going to spell my own name wrong. That's impressive. Woo! Sanford's general rule for mixed numbers. Always change mixed numbers to improper fractions. Before you do the math. To me, it's just a lot easier to do the math with improper fractions. You don't have to worry about borrowing or any of that. I'll show you what it looks like when we don't do this thing, because the book actually has you not do this thing a couple of different times, and I don't like it. I just like, let's just change them all to improper fractions, and then it's not an issue. Okay, so we're going to start out with an example. 2 7/9 minus 1 1/3. Okay, so we can do this. It is maybe a good idea to get a common denominator first. So if you remember our lesson from yesterday, when dealing with adding and subtracting fractions, we want to ask ourselves, do they have the same denominator? They do not. Second question, can one of them go into the other one? In this case, that's a yes. So we can leave this first fraction how it is, or mixed number, 2 7/9. And then for this one, we're going to multiply by 3 and multiply by 3, so we can get a common denominator, minus 1 3/9. Okay, now this is where the book and I differ. Okay, I would go ahead and change these to improper fractions. Now with the numbers that the book uses, you're going to end up with some pretty big numbers in your improper fractions, because they didn't intend to do it this way, but it's fine. So to change from a mixed number to an improper fraction, you take the denominator times the whole number, so 9 times 2 is 18, plus the numerator, so that should be 25/9, and then minus, and over here we've got 9 times 1 is 9, plus 3 is 12/9. And now we're just back to where we were when we started with the fractions. We have a common denominator. So the denominator stays, and then the numerators, we do the math. So 25 minus 12 is going to be 13. And from here, just right back into a mixed number. 9 goes into 13 one time, and 13 minus 9 gives us 4 left over the 9. And 4/9 can't be reduced, so we're going to leave it there. Okay, the book has you just go from this section, and this works some of the time. So if we can do the subtraction, particularly of the fractions, without having to borrow, then this way really is faster. You can subtract the whole numbers, so 2 minus 1 leaves us with 1, and then 7/9 minus 3/9 is 4/9. Okay, so the book's way is actually a little faster sometimes, but it involves having to borrow if this second fraction was bigger than this fraction. So it's, I don't know. This way will work every time. This way only works some of the time, is what I'm trying to say. Number 2. Okay, they've got the mixed numbers. Oh, I think I'm showing you the borrowing, what it looks like when we have to borrow or doing it the books way. So we've got 8 1/6 minus 2 1/3. Okay, and who knew you could do long subtraction with mixed numbers like this? It looks kind of crazy, doesn't it? So first let's get a common denominator so that we can do the math with our fractions. Since 3 goes into 6, we just have to change the second fraction. And so we'll rewrite the whole thing. 8 1/6, and then this one, it's going to be minus 2 2/6. Okay, so now do you see the problem? 1 minus 2 gives us a negative 1, and when we're doing long subtraction like this, we don't want to have a negative. So then what we have to do, and this is why I think it's more complicated, is we're going to borrow a whole from the 8 and add that in to this fraction. So just like when we borrow, this is going to go down 1, so that becomes a 7, and then we're going to add 6/6, which is 1, into this fraction. So this now becomes 7/6. And now we can do this subtraction. Okay, I'll rewrite it one more time. So with the borrowing and everything, we now have 7 7/6 minus 2 2/6. And here now we can do the subtraction because 7 minus 2 is 5/6, and 7 minus 2 again is 5. But the borrowing, I don't know, I think that's a lot more complicated of a process. If we go from having our common denominators and we just do it the Sanford way, Sanford way, we've got 8 1/6 minus 2 2/6. So we would change the mixed numbers to improper fractions. 6 times 8 is 48, plus 1 is 49/6, minus 6 times 2 is 12, plus 2 is 14/6. So like I said, we're going to get bigger numbers, but we don't have to borrow, and I like not having to borrow. So denominator stays the same. 49 minus 14 is going to give us 35. And then we ask ourselves, how many times can 6 go into 35? And 6 goes into 35. The closest is 30, which is 5 times. And if we take 30 out, that leaves us with 5 with the denominator 6. So we get to the same place. And really, you can use either way. I'm not going to, you don't get penalized for which way you do it. I just want you to know both are out there. The borrowing to me is a little more stressful, but hey, if you like it, go for it. Number 3, we're going to keep practicing. Now, here's an interesting bit. What happens if we just have a whole number and subtract a mixed number? What? You have a couple of options. First option is, how do we turn a whole number into a fraction? We just write it over 1, right? So really, this is 8 over 1 minus 3 3/4. Now we can get a common denominator. I'm going to multiply this by 4. And we have 32/4 minus, and I'm going to go ahead and change this into an improper fraction. 4 times 3 is 12, plus 3 is 15. So now, excuse me, we have 32 minus 15. Our fourths will stay. And if we do that subtraction, it comes out to be 17. And then we can change this back into a mixed number. 4 goes into 17, 4 goes into 16, 4 times, and that leaves us with 1 left over. Okay, so that's the Sanford way. If you want to do it the books way, we can borrow 1 out of the whole number, so that 8 becomes a 7, and to write 1 in a fraction that has the same denominator, if we want it to have a denominator of 4, and we want it to be equal to 1, it will be 4/4, right? That is the same thing as 1. So this still technically is 8. and then minus 3 3/4. And now we can do this subtraction. So we can do the whole numbers, which is 7 minus 3 is 4, and then 4/4 minus 3/4 is 1/4. So again, it's kind of less steps, but you have to really understand how to borrow. And if that doesn't make sense to you, just do the Sanford way. Change them to improper fractions and do the math. Some more practice problems because this is kind of crazy and complicated. Alrighty, let's do, we've got 5 1/5 plus 2 3/10. Now, since this one's adding, we don't have to worry so much about borrowing, but we might have to take some whole numbers out of the fraction. Let's find out. We might be okay if we do it the book's way. So let's get a common denominator first. Do we have a common denominator? No. Can one of the numbers go into the other one? Yes. So let's go ahead and use 10 as a common denominator, so I only have to change this fraction. We're going to multiply by 2, rewrite the whole thing, 5 2/10 plus 2 3/10. Okay, this one I can see we're not even going to have any carrying we're going to have to do, so book version, my version will take more calculating on this particular one. So I'm just going to do the book version. We're going to add the whole numbers. So 5 plus 2 is 7, and then we add the fractions. 2/10 plus 3/10 is 5/10. Am I done? No, because 5/10 can be reduced. We can divide both of them by 5. So divide by 5, divide by 5. The whole number stays the same. 5 divided by 5 is 1. 10 divided by 5 is 2. So there we go. That works out pretty well. Number 5. Let's see. 3 3/4 plus 1 1/2. Okay, now on this one, we're going to have some carrying if we do it the book way. So I'll do both ways so that you can see what that looks like. If we do it the book way, first, well, either way, let's find a common denominator first. So do we have a common denominator? No. Can one of the numbers go into the other one? Yes. So let's go ahead and use 4 as our common denominator. So I'm going to multiply the top and the bottom of this fraction by 2. Rewrite everybody, 3 3/4 plus 1 2/4. Okay, so if we do this the book way, now we're going to add everybody, add the whole numbers. 3 plus 1 is 4, and we add our fractions. 3/4 plus 2/4 is 5/4. Well, nuts. Now we have an improper fraction in our mixed number, and woo, craziness. So what we're going to do is pull out, or just basically what we would do to change this from an improper fraction. 4 goes into 5 one time. It's just that 1 gets to be added into our whole number. So the 4 becomes 5, and left over we have 1/4. Okay? If that was confusing, we can always go from here, change them to improper fractions. So 4 times 3 is 12, plus 3 is 15/4, plus 4 times 1 is 4, plus 2 is 6. And then we do our addition. We've got 4 on the bottom. 15 plus 6 is 21. 4 goes into 21. 4 goes into 20, which is 5. And we have 1 left over. Okay? So we get to the same place. Either way is fine. Aren't fractions fun? Oh, woohoo! All right, number 6. Just going to do a couple more. This time we've got 11 2/3 minus 2 3/5. Okay, so first thing that we've been doing is making sure we get a common denominator before we do anything else. Because 3 and 5 are both prime, and one does not go into the other, we're going to have to multiply both fractions by the other number. So this one we're going to multiply by 5 and 5. This one we're going to multiply by 3 and 3. So rewrite the whole thing. Have 11 and 10/15 minus 2 and 9/15. Okay, so in this case, looking at the fractions, we can do the 10 minus 9 without having to borrow, and so that's going to give us a lot easier numbers to work with. So let's go ahead and do it the book way on this one. So we can do the whole number subtracted. 11 minus 2 is 9, and then the fraction subtracted, 10/15 minus 9/15 is 1/15. Okay, and in that case, it really is easier to do the book's version. And number 7, 5 and 3/8 minus 4 and 11/12. Whew, 8 and 12. All right, now those have several common factors, and so this gets us to one of my very favorite multiples, which is 24, because 24 has so many numbers that can multiply to get to 24, right? It has, if we do factor pairs, we've got 12 times 2, we can do 6 times 4, we can do 8 times 3. There's so many different pairs, plus of course 24 and 1, that make up 24. So it's a very powerful number in that way. So notice that listing the factors of 24, 8 and 12 are both on there. So we're going to have 24 as our common denominator. So to get 8 to be 24 by multiplying, we times it by 3, times it by 3. To get 12 to be there, we multiply by 2 and by 2. So this becomes 5 and 9/24 minus 4 and 22/24. And see, this is where things get a little sticky now, because the 9 minus the 22, we're going to have to borrow. And I don't really want to borrow, but if we try to turn these into improper fractions, it's also going to be really big numbers. So let's give the borrowing a try, just because the improper fractions are going to be kind of huge. But how about we do both ways? I'll have to go, oh no, I've got it here. Okay, so we'll do it both ways. If we do it the book way and we borrow 1 out of this whole number, this 5 becomes 4, and we're going to add in 24 to the top number here. And so that becomes 4, and then 24 plus 9 is 33/24 minus 4 and 22/24. Okay, so again, we borrowed a whole. Essentially, we added 24/24 to this fraction, which gave us that. And now we can do our subtracting. The 4 minus 4 is 0, and then 33/24 minus 22/24 gives us 11/24. And that's really how the book intended you to do it. I will show you the Sanford way. We kind of get some large improper fractions, but that way you don't have to worry about borrowing. You still might want to use a calculator, though, to do your multiplying. So I'm going to write it down here. We're going to start with the 5 and 9/24 minus 4 and 22/24. So notice I don't go into the improper fractions until I already have a common denominator. Okay, so we're going to do 24 times 5, which is, and then add in the 9, and 24 times 5 is 120, plus 9 is 129/24. Whew, told you it'd be a big number. And then 24 times 4 is going to be 96, and 96 plus 22 is 118 24ths. Okay? Then if you want, we can even do the long subtraction, 129 minus 118, and you get a 1, and you get a 1, and you get a 0, and you'll see that we still get 11 24ths. So we get to the same place either way. If the borrowing stuff doesn't make sense, go ahead and just make everybody improper fractions. You might get some big numbers, so go ahead and use a calculator for your multiplication. But it's that way you don't have to worry about borrowing at all. Okay? Cool. Let me know if you have any questions. I'm happy to help. I try to respond to emails and Canvas messages as fast as I can. So, all right, bye.